Okay, now it's time for some examples, or some more examples, I should say. All right, so we're going to start with this one. Circle the angle with the greatest measure. All right, so we have angle 1, angle 3, and angle 4. So here we have angle 1, angle 3, and angle 4. It should be very obvious looking at it, but angle 1 is clearly the greatest. It looks more obtuse, right? It looks obtuse, and 3 and 4 look acute. Also, 3 and 4, that was supposed to be an arrow. Angle 3 and angle 4 are both remote interior angles, whereas angle 1 is an exterior angle. And so because of that, it is greater. Okay. I'm done with the accent. It's hard to do. All right, I'm going to erase all of these. Number 2, we got angle 4, which is right nya. Angle 5, which is right nya. And angle 7, which is right nya. All right, so same thing. So I don't know if y'all can tell, but this is a triangle. Okay, I know that there's a triangle next to it, but we're not worried about that triangle. All right, so you can see that 5 and 7 are remote interior angles, and then 4 is on the outside of the blue triangle that I just highlighted. So 4 has to be greater. Okay, so the one that's different, the one that's like outside is going to be the one that's bigger. So since the two of them were inside, the one that's outside is greater. Okay, let me get rid of all that. Angle 2, angle 3, and angle 6. Which one doesn't belong? So angle 3 and angle 2 are both inside the same triangle, so those are going to be our remote interiors. And then we see that angle 6 is by itself somewhere else. So the angle 6 is going to be greater because it's the exterior. All right, last one, last call. Angle 5, angle 6, and angle 8. This one should be easier for you to tell, but 5 and 6 are definitely inside. They're remote interior. And they're called remote because they're separate from angle 8. Like angle 7, even though it's inside of the triangle, it's not a remote interior angle. It's what do you call it? It's an adjacent interior angle because it's next to angle 8. That's the difference if you cared to know. Anyway, obviously angle 8 is greater. So, yeah. All right, example 4. Circle the larger, that's supposed to say larger, my bad, length in each pair of side lengths. Let's do it. What, Miss E, how they gonna ask me about side lengths when it's clearly angles right here? Baby, we did a whole theorem about that. Calm down, I got you. Okay, so first we're talking about LM, boom, and I'm gonna use different colors, LP, bow. Okay, so let's compare these two things by looking at the angle that's across from them, yeah? And then for this one, it's going to be this guy. Boom. All right, so which angle is larger? Wait, it says larger, right? Yeah, circle the larger one. So 83 is larger, which means that LP is longer than LM. Excuse me, so it's going to be LP. All right, let's keep it pushing. So we have MP, which is right there, and we have MN, which is right there. Okay, so let's figure out which sides are across, which angles are across. Okay, so that one's 44. And if you want, I'll do this to make it easier for you. And then, let's see, MP, the yellow one, is across from 79. Okay, which one's greater, boys and girls? It's this one. Does that help? I hope that helps. All right, I'm going to erase the other stuff because I don't like clutter. All right, next we have MN. So MN, and just using weird colors, why not? NP, cool. All right, so across from NP is 57, so I'll put a 57 right there to help me remember. Across from MN is 44. Which one's greater? NP is greater. All right, MP again, and LP. LP is the, oh, okay, my stylist just decided to go nuts. All right, so across from there we have 83 degrees, and that's for LP, so 83 degrees. And then across from this one we have 38 degrees. Well, obviously this one's greater. Okay, and that's how you do that, guys. Keep it simple. All right, moving on to example 5. Circle the larger angle. All right, so, but Miss E, again, these are side lengths. You told me if it's on the outside, it's for sides. Yeah, you're right. But again, we can use the sides to help us figure out which angle's bigger. So let's see. Angle ABD. So start with A. Let me use my highlighter. I'm going to start with A. Go to B, go to D. Okay, so this is ABD right here, this little corner. And then we got angle A, which is right here. All right, so which one is greater? Well, let's see. A is across from 35, so I'm going to put 35 here. And then B is across from 39, so I'm going to put 39 here. Which one is greater, y'all? 39 is greater than 35, so that's going to be the larger angle. Okie doke. Let's erase that and go on to the next. Angle C. Okay, that one's easy to see. It's over there. And CDB. CDB. Okay, so we're talking about this little corner right here. All right, which one is greater? Well, let's take a look. This one's across from 34, so that would be CDB. So that's 34. And, oh, I'm doing the wrong one. Sorry. 34, and then angle C is across from this 35. All right, which one's greater, 34 or 35? 35 is greater than 34, so that's going to be your larger angle. And then last but not least, we have CBD, hardy hard. So that would be this little corner there, and then CDB. Okay, so that's this little corner here. All right, so let's figure out which one is larger. This one's across from 34, so that would be 34. And then this one's across from 41, so that would be 41. 41 is obviously greater than 34, so that's the one we want. Okay. And what did we get for number 9? What was it? A, B, D. That was across from 39. And then angle A was across from 35. Okay, so this one. Okay. All right, moving on to example 6. Determine whether the given measures can make the lengths of a triangle. All right, so here is the thing. Don't forget triangle inequality theorem. The two of the sides, if you add any two of the sides, they will be greater than the other side. So I would say take the two shortest sides, add them together, and make sure it's greater than the biggest side. Obviously, if you take the biggest side and add it to a shorter side, it's going to be greater. So I would say take the two smallest ones and see if it works. All right, so for example, this would be 7, and 7 is greater than 6. So yes, that would make a triangle. Let's see, 4 plus 8, that's 12. 12 is not greater than 16, so that would be a no. Here and here, we got 2 plus 4 is 6. 6 is greater than 5. That would be a yes. Again, always take the two smallest sides. That's the little shortcut. 8 plus 8 is 16. 16 is definitely greater than 8, so that's a yes. Let's see, 6 plus 9 is 15. 15 is equal to 15. That is a no. And then we have 1.5 plus 2.5, which is 4. And 4 is less than 5, so that's also a no. Okay, so that's the shortcut. That's the shortcut to, where is it? This. That's the shortcut to doing this. You don't have to do all three. Like this example did all three. Just pick the two shortest sides. So like the 7 and the 8, add them up and make sure it's greater than 9. All right, moving on to example 7. Alan, Brendan, and, ouch, I'll hit my elbow. Carl were standing in triangular shape, blase, blase. All right. Find the measurement of each angle and determine which two guys are standing the furthest apart. All right, cool. So this is a double whammy. We got some stuff going on here. We got some stuff from the last unit plus the stuff from this unit. So first thing, how the heck are we going to figure out what x is? That's the first thing. When life gives you 3 angles in a triangle, add them to make them equal 180. All right, so that's going to be 7x minus 5 plus 5x plus 10 plus 4x plus 15. And then make that equal 180. Okay, I learned my lesson last time. I have to have the calculator open first. See what happens when you think. All right, so let's put that at the bottom. Okay, so we have 7x minus 5 plus 5x. First of all, where is my end solve? Since I'm solving an equation, I need to have end solve. What a concept. Minus 5 plus 5x plus 10 plus 4x plus 15 equals 180, comma, x. Okay, and what do we get? I can't see. 10. Okay, so that would be x equals 10. All right, so now we need to plug that back in. So we got 5x plus 10, so that's going to be 5 times 10 plus 10. Well, that one's easy. That's just 60. Okay, then the next one is 7 times 10 minus 5. 7 times 10, which is 70, minus 5 is 65. So that's 65 degrees in that corner. And we got 4 times 10 plus 15. That'd be 40 plus 15, which is 55. That's 55 in that corner. Okay, so I don't need this anymore. Oops, didn't mean to do that. Okay, and here we are. Okay, so which distance? Okay, so the largest angle here is 65, which means that the distance between Alan and Carl is the longest. Oops. I'll just write it like this. Alan and Carl are the furthest apart. All right, example 8. Triangle ABC has the coordinates, blah, 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 blah. Y'all can read, boom, boom, and boom. Find the length of each side of the triangle and then list the measure of the angles from least to greatest. Do you know what, gentlemen and ladies? Ladies and gentlemen, we're going to omit this one, okay? Okay. All right, going on to example 9. All right, so we have this. Oh, this is a mid-segment problem. All right, let's do this. Because it says midpoints. U and B are midpoints. So U and B are midpoints, which means that's equal to that, that's equal to that, okay? All right. Oh, and T as well. 1, 2, 3, 1, 2, 3. Okay, so this is definitely a mid-segment problem. So this is a mid-segment problem. It helps to know what kind of problem it is, because some of y'all just be all confused because you don't know what kind of problem it is. So now we got to figure out TU. Okay, this one's simple. All right, I'm going to erase all that. All right, so TU, we got to find TU. So the good news is we know the side that's parallel to it. So since this whole thing is 40, this is just going to be half of 40, which is 20. So TU is just 20. That's how that works. I told you that was easy. Did I tell you that? I don't know if I told you or not. All right, so I'm going to erase. Actually, I'll leave it there. All right, so next we got to find UB. Where's UB? Oh, that's not the color I wanted. Okay, UB, which is parallel to QS. So the sides that are parallel are going to have that half relationship. So since QS is 50, half of that is 25. So UB is just 25. All right, QR, which is here. All right, we got to figure out what QR is. We know what QB is. Oh, sorry, my bad, TB. All right, so TB is 30, which means that QR has to be double that. So that's going to be 60. You see how that goes? Because it's the bigger side. So if it's, the bigger one, it's going to be doubled. If it's the smaller one, it's going to be half. And that's it. All right, number 10. Let's do it. All right, so this one, since it's another mid-segment problem, don't forget that this one is going to be half of this one, okay? So the way we can set that up is that the long side equals 2 times the short side. So we got 5x minus 4, that's the long side. That's going to equal 2 times 8, because that's the short side. The 8 is the short side. So 5x minus 4 equals 16. All right, so you can solve it using nsolve, or you can solve it by hand. I'm going to solve it by hand real quick. And then we get x equals 4. And of course, you want to check your answer by plugging it back in. So 5 times 4 minus 4, that would be 20 minus 4, which would be 16. And this was supposed to be 16 because this is supposed to be half of 16. So we did good. All right, last example. Yeah, it's the last example. All right, so same situation. Don't forget the long side equals 2 times the short side. Okay, so the long side is 72. And that'll be 2 times the short side, which is 6x. So that's going to be 72 equals 12x. All right, and if you divide both sides by 12, you get, what was that, 6? Just had a whole brain fart. All right, so there you go. And of course, you want to check your work by plugging it back in. 6 times 6 is 36, and that's half of 72, so we're done.